Okay, so let's start with the economic geology classes, and we are going to start with Walther Pohl. Now, Walther Pohl, he was the, it's not written, the professor of which department and which university anyway. So it's a very good book. So let's start with Walther Pohl. We'll continue with more books as well. Okay, so economic geology, the principles and the practice. Okay, so we will be learning about the metals, the minerals, coal, hydrocarbons, introduction to formation. The how are the ores forming, the formation, and the sustainable exploitation. Sustainable exploitation. Okay, the word sustainable is important. Okay, it's not like you are, if sustainable means what? If I consider the ore reserves or resource as 100% and you are entirely using up 100%, then that's not sustainable. You have 100% and out of that maybe you are using 60%, then that's sustainable. Or 100% and you are using um, 50 percentage, again that is sustainable. So sustainable exploitation is the is another, it's a study in itself. So that's something that is very much looked into by the government and the companies, the government especially. So first of all, we will be starting with what are the ore deposits. What is an ore? Ore is a rock. The mining in the stress field between society and environment, mineral resources conundrum, then the metalliferous ore deposits. So metals, geological ore formation processes, systems, metallogenesis. The word genesis means what? Origin. The magmatic ore formation systems, orthomagmatic ore formations, ore deposits at mid-oceanic ridges and in ophiolites. So you have ores in the mid-oceanic ridges and also in ophiolites. So yeah, that is it. We have the ore in the mid-oceanic ridges, and we also have the ores in the ophiolites. Ore formation related to alkaline magmatic rocks, carbonatites, and kimberlites. Uh, we do have ore formation related to the alkaline magmatic rocks, the carbonatites and kimberlites, granitoids, and ore formation processes, ore deposits in pegmatites, hydrothermal ore formation, skarn and contact metasomatic ore deposits. Then we have the porphyry copper with molybdenum, gold, tin, tungsten deposits, hydrothermal metasomatic ore deposits. Hydrothermal metasomatic ore deposits, hydrothermal vein deposits, and volcanogenic ore deposits. So these are all the magmatic ore formation systems. Okay, then we have the supergene. Okay, the supergene ore formation systems, residual or alluvial ore deposits, supergene enrichment by descending or vadose, vadose solutions. This word, vadose, vadose. Infiltration as an agent of ore formation. Okay, it's agent of ore formation, infiltration. Then we have, so this was all about supergene, and then when we come to sedimentary ore formations, where there is black shales, metallogenesis, placer deposits, autochthonous iron and manganese, iron and manganese deposits. Then we have the sediment hosted submarine exhalative SEDEX base metal deposits. Okay, so these are the sedimentary ore formation systems, sedimentary ore formation systems. So, yeah, sedimentary ore formation, sedimentary ore formation. Then we have the diagenetic ore formation when there is diagenesis involved. Diagenesis is involved. European copper shale. Okay, diagenetic hydrothermal carbonate hosted uh, lead zinc. Okay, fluorine and barium deposits. Diagenetic hydrothermal ore formation related to salt diapirs. These are the diagenetic, metamorphic, and metamorphosed is the next part. So metamorphic and metamorphosed ore deposits, and then metamorphogenic. Then we have metamorphogenic finally. Um, Metamorphogenic. So there is this difference between these two things, like metamorphic and metamorphosed and metamorphogenic ore formations. Then you finally get to the, like, this is the metallogenic epochs, the provinces, and the plate tectonics. And the genetic classification is a summary basically of ore and mineral deposits. So this is it. This is the ore forming part. Okay, this is the ore forming processes part, and this is the economic geology part. Economic geology means we are learning about the metals, we are learning about the minerals. So therefore, iron and steel, we have iron, manganese, chromium, nickel, cobalt, molybdenum, tungsten, vanadium. For the base metals, we have copper, lead, zinc, tin. So copper, lead, zinc, and tin. These are the base metals. Then we have precious metals. We have gold, silver, platinum, and PGE. Okay, so PGE is important. Uh, PGE, we have to learn about PGE. Then we have the metals. Light metals are aluminum and magnesium. It's minor and specialty minerals are mercury, antimony, arsenic, byproduct electronic metals, selenium, tellurium, gallium, germanium, indium, cadmium. You see the selenium, gallium, germanium. A lot of semiconductor metals are also there. Silicon. Then we have bismuth, zirconium, hafnium, titanium, REE. Okay, REE. Lithium, niobium, tantalum, beryllium, uranium and thorium. So these things are important. The specialty minerals. Okay, so we in the specialty we have the critical minerals, which everyone is talking about. The entire world is talking about the strategic, the minerals that is needed for the war purposes, and the minerals that is needed for the environment purposes. So these are there in the specialty minerals. Okay, so specialty minerals, again, this is important. This portion is important. Okay, then we come to the non-metallic mineral and rocks. We have industrial minerals, earths, and rocks. We have the Andalusite, kyanite, sillimanite, Andalusite, kyanite, sillimanite. We have asbestos mineralization types. We have barite, BaSO4 and celestite. Geochemistry barite deposit types. We have bentonite. Bentonite is the smectite rocks. Okay, then we have boron, geochemistry boron deposit types. We have the carbonate rocks with the limestone, calcite, marble, marlstone, dolomite. So we have the limestone, we have the metamorphic calcite, and occasionally dolomite, marbles, marlstone, and dolomite. Clay and clay rocks, clay deposit types. Diamond, we have the source and formation of diamonds, the diamond deposit types, the diatomite and tripoli. Diatomite deposit types. Tripoli was there. Then we have feldspar, fluorite, geochemistry and fluorite deposit types. Then we have graphite, the graphite deposits types, gypsum and anhydrite, deposits of gypsum and anhydrite, kaolin we have to study, then kaolin deposit types, the magnesite deposit types, mica, we have muscovite, phlogopite, vermiculite, muscovite and phlogopite, vermiculite. Um, Okay, see, we these things are important. Like mica is a huge group, and but these things are important. Olivine again, olivine deposits, phosphates, geochemistry, phosphate um, deposit types. Again, just because I remember this name, Jhamarkotra for the phosphates. Quartz and silicon, quartz deposit sites, quartzite, sediment, metamorphic quartzite deposits, and sedimentary. So, metamorphic and sedimentary both, quartz, sand, gravel, industrial sand and gravel, building sand and gravel. So, sand is important, gravel is important. Then we have the carbonates, sodium carbonate, sulfate, alum. Okay, sulfur. This is important. Sulfur is important. Okay, sulfur, sulfide, sulfates. Sulfur is important. Then talc and pyrophyllite. Talc depositize pyrophyllite, volcanic clastic rocks. We have the pumice, perlite, and trap. Wollastonite deposits, zeolite deposits. Then there is salt deposits, which are the evaporites, the salt minerals, the rock salts. Okay, so salts. The salt deposits, salt formation, the salt formation of geological past, post-depositional fate of salt rocks, diagenesis and metamorphism of evaporites, deformation of salt rocks, formation and structures of salt deposits, supergene alteration of salt deposits, from exploration to salt mining, exploration and development of salt deposits, geological practice of salt mining. Summary and further reading. Then we have the practice of economic geology, geological concepts and methods in the mining cycle, exploration, exploitation, and closure of mines. Okay, then we have the economic considerations, the search for mineral deposits exploration, pre-exploration stage, before exploration, then the geological exploration, then geological remote sensing, geochemical exploration, then we have the geophysical exploration, the trenching, and then drilling. Okay, development and valuation of mineral deposits, geological mapping and sampling, geological mapping and sampling, ore reserve estimation, determination of grade, valuation of mineral deposits, mining and the environment, potential environmental problems related to mining and mine site processing plants, deep geological deposition of dangerous wastes. Okay, this is important. We have nuclear waste deposition here as well. Like nuclear waste is deposited in Jadugura, India, in Jharkhand. Jadugura in Jharkhand. Okay. Then we have the fossil. Fossil. We have coal. uh, Coal types, petrography of coal, chemical composition of coal, the peat formation. Okay, so we have the peat formation, types and dimensions of the coal seams, concordant and discordant clastic sediments in coal seams, peat formation, environments, host rocks of coal, marker beds in coal formation in geological space and time. We have the qualification process. We have biochemical petrification, geochemical qualification, biochemical petrification, geochemical qualification, measuring the degree of coalification, causes of coalification, coal maturity, and diagenesis of country rocks. Then the post-depositional changes of coal seams, the tectonic deformation, epigenetic mineralization of coal seams, exogenic alteration of coal, and then we have the applications of coal geology, exploration, reserve estimation, coal mining geology, environmental aspects of coal mining, especially, etc. Then we have petroleum and natural gas deposits. Uh, in petroleum and natural gas, I think this is the last portion. The final portion, we will be studying about the natural bitumens, the gas, the kerosene, the properties, crude oil and petroleum, natural gas hydrates, tar, earth wax, ozoceride, pyrobitumens, natural asphalt, the kerosene, origin of petroleum and natural gas, petroleum source rocks, dry gas source rocks, geogenesis, catagenesis of kerosene, oil window, formation of petroleum and natural gas deposits, the migration, the reservoir rocks, petroleum and gas traps. Then we have the formation and reservoir waters, alteration of petroleum and reservoirs, degradation, tectonic environments, and age of hydrocarbon provinces. Exploration for exploring the petroleum and natural gas deposits, geophysical. So exploration part is there now. Geophysical methods, geochemical methods, exploration, drilling, geophysical borehole measurements, exploitation. Okay, petroleum and natural gas reservoir conditions. This is oil and gas field development, oil and gas field production, petroleum mining, reserve and resource, alada alada, different things. Estimation, post-production, uses of oil and gas fields. Okay, then we have tar, sand, asphalt, pyrobitumen, shungite. Tar sand, asphalt, pyrobitumens, and shungite. Then we have the oil shales. We have the environmental aspects of oil and gas production. Water resources production, induced seismic activity, tar sand mining, hydrocarbons, and climate. So that is it about the index of the book. We will keep it till this much and continue with the next part. Thank you.